Hi, hello, how are you? Good day to all of you, and Dr. Shiva here. I'm very glad to meet you again for the vector calculus, and today we're going to continue with the vector calculus. The subtopic that today I'm going to cover are three: one, divergent; second, curl; and the third one is line integral. I'll try to introduce to you for the line integral. I will introduce to you a few methods which maybe it will may cover today, and it may continue as well, and which is very extensive topic in the vector calculus. Therefore, I hope that all of you manage to follow some of you following my class, and I notice many of you still didn't mark your attendance. Okay, for this video, make sure after you watch the video, please mark the checkbox and make sure that your attendance is is marked. That is very important. Okay, therefore this attendance will be used because for the verification of the verification. I will make sure after this I will give you quizzes to assess your level of understanding. Therefore, please make sure that all of you are able to follow the lecture notes. Okay, I know that some of you may have a problem. As I said, if you have any problem, this Wednesday I'm going to have a WebEx meeting with you. You can highlight the issues, okay, some difficulties or setback. Again, I just want all of you to follow. Take a paper, just a pen, follow my lecture notes and copy the notes carefully, step by step. If you don't understand, please let me know where do you have difficulties. Okay, some of you, those are very strictly followed my notes, the previous notes. Some of the students commented. Okay, some of the students commented my notes. Some, not to say one or two, because they noticed some of my mistakes. That is very good. Okay, that means they managed to copy as well as they able to understand some of the mistakes, small mistake. One of the mistakes that some of the students managed to highlight to me quickly and say, "Sir, you made a mistakes here." Okay, the mistakes that I want you to take note on this is the example. Okay, the previous example from the directional derivative. Find directional derivative of, this is example number 2 if I'm not wrong, directional derivative, the first example, sorry. You can see the student managed to notice this mistakes. X power supposed to be as power 3 and y power 2 at the point -1 in the direction of this, because you see I'm solving this equation as this 3x2 y power 2 is supposed to be a 3. Okay, this is one of the very good sign that you're all following my lecture note very closely. Okay, thank you very much for your comments, and I really appreciate that. Okay, if sometime I made mistakes also, you are able to quickly you're able to respond to me. Okay, as today, as I say, I will continue with the divergent, curl and line integral. Okay, this topic is quite extensive as well, and let me start with the divergence. Okay, divergent basically is a scalar Okay, scalar is a magnitude based method whereby is to find the change the change of volume density. Okay, divergence will be used to find the change of volume density. Okay, now in simple, divergence can be explained as outflow from any volume, okay, minus inflow of volume density. Okay, now based on this, we're going to analyze how do we able to calculate the magnitude of divergence. Okay, divergence basically, as you all know, nabla is something similar to del x to the I, del y, del z to the k, and there is a vector. I'll give you a vector whereby the vector I call it as a function fi gj hk. It's a vector. And previously I've given you something. The dot product always will produce 1. Okay, for the maybe I'll put it II, and kk will give you 1 as a solution. Therefore, the definition of the divergent can be explained as this. Okay, delta dot f, which is sometimes some books they will refer that as a diff f. Okay, diff f. In actual combination of this diff f and jj to the vector, we can combine together the nabla and f. You will get del f del x, okay, plus, okay, what happened to the I become a 1, okay, you times with this, f will go inside, I, j, k, it will produce 1. Therefore, you will get del g, del y, del h partially differentiated of f towards x, and partially differentiated g to dy, del h to del z. Okay, this value is a scalar value. Okay, this value is a scalar value. Okay, now some of you may ask me, sir, I didn't get it exactly what you are trying to say, because you say you started with outflow, inflow, and here is a volume. Okay, it's a volume density, and could you put that into better elaboration on this? Okay, let me draw to you later. Okay, but let me just again, I put this as a quick definition. Diff f can be defined as del dot product with the f, and this is basically the definition of inflow minus outflow with the inflow volume density. Okay, now I'll give you some sketch on this for you to understand what is inflow and outflow. Okay, the outflow, how do we able to visualize this? Okay, in practical, let us take it as a surface. Okay, volume means, as you all know, volume, right? But we first, let us go one by one, step by step. Let's say this is a surface. Okay, we imagine this is a surface. Okay, surface. Okay, inflow, maybe it could be inside. This is a inside, this is outside. There will be a two face, right? Interface. One is outside. What I mean by inside and outside, later we will define. This can be a bottle. Okay, then I'm trying to visualize this bottle or a box or whatever. Okay, we imagine this is inside and this one, this surface is outside. Therefore, we will call it this anything. Let's say the water coming out of one small hole here, let's say, then we call it this as a outflow. Okay, outflow. And something, let's say the water go inside, we call it that as a inflow. Okay, this is a simple definition. Okay, simple definition for you to understand. Let's say in a simple, generally when we call it diff f, okay, when we define diff f and del f dot product to the f greater than 0, this means very simple. Again, this is a outflow minus inflow is a greater than 0. Okay, therefore in another way we may say the outflow is a greater than inflow. Okay, in average overall. Okay, there might be an inflow and outflow, but in average we can see outflow is a greater than inflow. Therefore we can sketch these logics like this. Okay, the outflow is a coming out. Okay, coming out of any small the water coming out from the surface. Okay, this might be, or in another term we may call it that as a kind of from your eye perspective, when you see this surface, it's a kind of like a expanding. Okay, it's a kind of like a expanding. Okay, the things are expand from that point, the particular point. Okay, you can see water is expanding. Okay, similarly, when we start observing the similar case, okay, diff, for the case diff f, which is equals to del f to the f, outflow minus inflow less than 0, where the outflow is less than inflow, we can imagine this as something, the water going inside. Okay, in average of course there will be average when in the state of equilibrium, of course, as you all know, the water flow and in and out are same. But in this particular case, we can imagine there is a water, the average water inflow is higher than outflow. Therefore, we can imagine this as at that particular point, the surface is something going inside, right? Okay, if I try to magnify this. Okay, therefore this is a kind of what? It's not expanding, it's actually a contraction. You can see that. Okay, kind of contract, but actually it's not a contract, it's going inside. Okay, one is expand. Okay, I want you to just, it can be a contract, you see, contraction. Okay, contraction. it could be a kind of a moving inside. Okay, search inside, that means it's moving inside. Okay, now with this is a very simple, actually divergent is a simple, but we're going to use divergent very extensively later for the very advanced application for the theorem. Okay, therefore we are learning now is the component of divergent, the concept of divergent, and this divergent will be further incorporated or will be embedded into the theorem called divergent theorem. Later I will introduce to you the divergent theorem, but before that I want you to get this simple knowledge. Okay, let me give you the example. Okay, the example is very straightforward. Evaluate dot product with the f, where f is 2x2 zi. I don't know whether you all can see. Is it a too small to you? Some of you may say, sir, too small, sir. Okay, can you help us to make it a little bit more? Okay, I try my best to make it as big as possible where you can see this. Okay, evaluate fx where f is then x y2 zj plus 3yz to k. Okay, at point 111, and you can imagine this thing, these functions as f, g, h. Okay, therefore when I combine together del x I, del y j, del z to the k, dot product with this, you imagine this as fi, gj, hk as a dot product to this, where you will can able to combine back. You see, I again, as I say earlier, del f, del x, okay, del g, del y, okay, del h to del z. Okay, therefore this is a very simple to work with, right? Now you know separately you can differentiate, partially you can differentiate. Therefore del dot f in a simple definition, you can differentiate this to 4zx. Please make sure you are doing partial integration properly. yz, okay, 6. Okay, what is the results if I just place f as a 1 1 1? Okay, just you substitute the value where you get 4 2 6. Overall you will get it what we call as a 8 12, right? Okay, what you understood with this? Okay, what is the explanation for this? This is greater than 0. Okay, greater than 0 means practically you can see the water coming out, okay, from the surface. Okay, it's a simple logics of that, outflow minus with inflow greater than 0. Okay, that is the definition of this. Okay, with this, simple, right? So far I hope that you can follow. This is a very simple method in the initial state lah. I hope that at least you can follow. Okay, then later we're going to combine this into the advanced theorem. As I say, please make sure you can understand the simple process that I introduced to you. Now I'm going to introduce to you something called curl. Okay, I'm going to introduce to you what I call as a curl. Therefore I'm going to use a new page, it's easier. Okay, Now let me introduce to you curl. Okay, the curl is a very important component. Curl. Okay, curl is one of the very important component of the vector calculus, and it will be used very extensively later again for the another theorem called Stokes theorem, which will be very challenging. For the divergence also is quite challenging. Okay, the theorem will be a little bit might challenge you, but the curl is a very extensively it may challenge you. Okay, therefore I want you to properly, okay, carefully understand the process. Okay, this is a method. What is this curl? The curl is a measure, okay, angular velocity. Okay, angular velocity. Okay, when you say curl is to measure angular velocity, I don't understand what mean by angular velocity. Is there any possible for me to explain this? Okay, let me to put you what is this angular velocity. Okay, what can be a very simple. Okay, Earth, take it the Earth. Okay, you can see this is a sun. Okay, Earth is a moving around. Okay, revolving around the sun. When the Earth is moving around this sun, there is a what we call angular velocity. Actually, Earth is not moving this direction, right? It's moving, okay, in every step. It's moving in an angular, right? Moving in an angular. Therefore, it's using angular velocity. Okay, when we make a similarly, can we capture this? Okay, of course, for the curl, a curl will observed for the particles. Okay, we're going to see the charges, okay, small electrical charges in electromagnetic wave or in any okay, electrical field and etc. Therefore, it can be used for the quantum what do you call analysis. Okay, but we can use it the logics here also, okay, for the angular velocity for the bigger scale as well. Okay, but anyway, as I said, now you know what I mean by angular velocity, right? Okay, there is a velocity. Of course, the velocity is not calculated for the direct, okay, linear. Okay, there is an angular. Okay, now in this particular case, curl will be measuring. Okay, it will be used measuring the angular velocity at any point of the vector field. This is very useful information. Vector field. Okay, measuring the angular velocity at okay, can you see that it's not a knot, at any point of the vector field. Okay, it will able to measure the angular velocity. Therefore, is Fi, take it as J HK. It's a vector. We call it this as a vector. Okay, it's in a vector. Therefore, the curl will be defined as curl F, or we will use as a nabla product, okay, times with the F. Okay, times with the F. Then this equations basically for the case of vector field, you need to use matrix. Okay, matrix to calculate. Therefore, the definition of this will introduce to you this logic is called del x, del y, del z. Okay, f g h. Okay, and this able to give you again, previously I did explain to you, okay, for the calculation, basic, in order to use the times product here, you need to hide I first, then you just times these two, and you place the I inside. For example, I show you, this is del H del Y minus del G, okay, del Z, which is I, okay. Then the next one is a minus, okay, which is del H and del X, del F, del Z, okay. Those follow my previous vector class, intro class. Definitely you should be able to do it this, but only the difference you can see is we are just placing here, okay, the H will go inside here, okay, G will go inside here. Here we are not times, actually we are placing. That means is we are doing a kind of times anyway. The logics here is we are creating del H to the del Y, okay, del G to the del Z, okay. Now in this here, del G to del X, del F to del Y and K, okay. This is vector, okay. Therefore the simple question again you may ask, sir, is this curl is a scalar or vector? Definitely is a vector, okay. You can see this is a curl is a vector, it's not a scalar, it's a vector, okay. Vector means it has two things, one magnitude and direction, okay. You can see the calculation producing magnitude or magnitude and direction together, okay. Now we can see here the definition, as I say, is angular, right? Still I can see some of you bit not very sure what is this angular vector, right? What is angular? Okay, can I give you further explanation on this? Okay, the angular, for example, I'll give you one very simple concept, okay. If there is no angular, okay, let's say there is no angular, that means it's a zero, right? No angular velocity. That means the vector field will be all linearly directed, okay, linearly directed, or you can see the progress will be like straight, linearly directed. It can be a horizontal or vertical, okay, or opposite of these directions, vice versa, see. But it's not angle, there is no angle, okay. Angle, as you all know, it should produce some kind of angle right here, okay, referring to the some theta, okay. There is no angle, the change is straight and linear, okay. Now therefore we call it this as a none of points having angular velocity in the vector field, okay, vector field, okay. And this is very important message that I want to stress to you. The word for this is, just now I forgot to mention this word, very important. How can I miss this word? It's actually we call rotational, okay, rotational. Therefore if this is, we call it as a irrotational, okay, irrotational. And later we're going to use this irrotational field is equivalent to what we call as a conservative, okay, relational form. In the vector relational form we're going to analyze is vector in a relational form. I will explain to you this part later very extensively. We're going to do some workout for this conservative. But anyway, irrotational. You can see, is it irrotational? No. Okay. Sorry, is a rotational? No. This is a irrotational. Okay. What about the if del times with the f not equivalent to 0? This is rotational. Okay, rotational. This means we can see the points have angular. The points have angular velocity. Okay, you can see the points. Okay, all the points here. Okay, maybe I sketch some sketching here. Okay, for this vector we will do a lot of sketching. You can see later it's a lot of sketching you will see. Okay, this is you can see something rotational. It rotates. Okay, it's a kind of rotational. It's an angular velocity in a smaller scale also, but it's you should be able to see some angle. Okay, it's not a irrotational straight. Okay, rotational is 0. Okay, when you start seeing this, now as I explained to you, there is some angle between, then there is a point. We can see there is an angular point, and it's not a straight. Again, I repeat this word is they must have some angular. Then only we will see it will go straight. Most probably it may go straight in a few lines, then slowly it will take up like that. Okay, it may rotate. Okay, it may rotate. Okay, in this particular case, again for the surface, okay. Okay, there is a, you can see there is an angle. Okay, then once on the surface, then it will, you can see the angle. Okay, I hope that I have given enough explanation for this. Okay, now let us do one simple quiz. Sorry, not to say quiz. Okay, very soon I will give you quiz anyway. Okay, very soon I will give you online quiz. Okay, now let us do one simple example. Practice, most probably you can, I hope that you all can. Okay, the question is 6xy plus z3 I 3x2 z j plus 3xz2 minus y k. Simple question to make it. Is it irrotational? Okay. Okay. They wanted to know whether it's irrotational or not. Okay. What we all understood with the word irrotational. Okay. Irrotational again. Irrotational means the sketch will be straight, or it could be in any direction, but it should be a straight line. They should not be any angular. Okay, how to do it this? Okay, this we can define as something called del to the f. Okay, del product to the fi. Okay, here del, choose del x, j, del y, k, del z, and this can be explained as 6xy z3. Okay, you just choose all the x2 to the z, 3x z to the y. Okay, now you can see this. Okay, now we need to do step by step. Remember, first you hide this and start working on this product times with this and times with this k, j. Okay, under the column of this. Okay, now let us check one by one. Okay, when we start work on the steps here, del 3xz, sorry, 3xz2 2 this is y. Okay, this is y. Okay, minus, okay, del z 3x2 to the z. Okay, I'll do step by step here. It's easier for you to okay, minus, okay, minus, maybe I put it this as first, what is this, del y. Okay, then we can see we can handle this problem as the next to the del x 3xzy minus z 6xy z. Okay, how am I doing this? J, okay, when I hide this j 3x, okay, you can see yeah, this 3xz minus y times with this, you get the k. Okay, now plus, I'm doing in a bigger scale bit. Okay, at least you all can see. Not a k, is it correct? It's not a k, it's a j. It's j. Okay. Okay, now for the third one, you just hide here, then you can get it this one. Okay, in this particular case you will able to handle the okay, if I hide here this, you will get it 6xy plus z3. Oh, sorry, what am I doing? Okay, this, if I'm start working on this, okay, the first thing should be, okay, can I, sorry, just I put it here, I don't want any confusion anyway, just I cut this, sorry, then you just times with this and times with this. Okay, therefore it's easier for you to just del x 3x2 z minus del 6xy plus z3, okay, y. Okay, and this is overall will be called as k. Okay, k. Okay, this is simple. Okay, this is simple. Actually, you may say I'm not struggling here. Basically, I'm quite worried. Some of you can, if I can see you, then immediately I know whether you all following me. Then I can write, I can make a correction. But here I'm recording, therefore I quite although I'm prepared with this, but I just wanted to take a flow. I want all of you take a flow by yourself. Okay, you should able to see, okay, I'm doing this because I'm getting this. Okay, it's not simply, I don't want you to listen to this like a kind of listening. This is not a listening task or lecture, but I want you all to in your mind, you should able to work by yourself together with me. Okay, therefore I wanted to ensure that all of you can follow me and understand the steps, every steps. Okay, this is how am I doing, because it's impossible for you to ask question back, right? You cannot raise your hand, sir, I don't understand. Okay, therefore only I have option is I need to make as slow as possible. I need to make sure whether you can follow the steps carefully. Okay, that's why I'm going a little bit thorough. Okay, now can we say it's a irrotational, right? If I say it's a rotational, I need to make sure irrotational should produce the answer equal to 0. Okay, should produce equal to 0. Is this answer will produce to me 0? Okay, let us check whether do we get the answer 0. Okay, when I say del y to this, okay, I will get a -1, right? -1. Okay, -1. And check back again. What about this? Del z, okay, minus -1 again. Okay, -1. That means the whole thing cut off 0, which is you will get a I. We don't care. Okay, once it's become a 0, the whole thing become a 0. Okay, correct? Then similarly, okay, when you start working on the second one, you in this particular case is a z, right? Okay, here 3z2. Okay, this one. Okay, again similarly for the case here, minus this one is obvious, positive, right? This one, okay, I'll put it again, negative. Since this is a bracket, I wanted to make sure. Okay, this is a 3, -3z2. Okay, which is basically is a again you are getting a j and you will get 0. Okay, you will get 0. Similarly, you try and see this one. Okay, x, 6x, and over here you get a 6. Okay, 6x, here you will get a 6x, therefore you will get 0 again. Here for the k also you will get a similar, therefore over here you are concluding this is a 0. Okay, now